nature of our relationship. But I'm not sure exactly. Okay, we'll give it a second. All right. So in the interim, as we work out our technical difficulties, this is what we're talking about this evening. This is my cool shirt that I had made, and it says End H3C. Now, H3C it stands for human caused climate crisis, which is an H and three C's. Let's call it what it is so that there is no equivocation. It is a crisis that is caused by human activity. So that's kind of what we're here for this evening. We have some great scientists that you'll be hearing from. Dr. Peter Mahaffey from King Center for Visualization of Science, which is a wonderful resource that I have used to find out about climate issues. It's a great way if you have students to take them in and show them certain things about the atmosphere, and I'll let Peter tell you about it, okay? And then we also have Catherine Hayhoe, who is probably one of the most, in my estimation, prolific science climate communicators on the planet. She, of course, is a climate scientist. You may have seen her TED Talk, but she is one of the people that makes it so very plain, and I call her a crystalline voice with respect to the climate crisis. Neil?
Yeah, hey.
Hey, there's Neil.
Can you hear me?
I can hear you. Oh.
Thank you for bringing everybody in while I'm messing with my technicalities.
No worries. I love the vest. Look at you. We must be doing something special. You dressed up for the teachers. The teachers are special. The teachers are special.
You're not gonna wear my Sunday best.
We have been together since March on Zoom. I haven't seen you. The last time I saw you was in March. And this is the first time I have seen you.
Let me turn it back on you. Is that the best you can do, is wear a T-shirt for this event?
It's a very important T-shirt. Yes, it is.
So you did some introducing while I came in. So this is our first live on virtual, right? So did you cover that?
I did not.
Yeah. So people, just so they know, we do this often during the year, several times a year in theaters on a stage where we have guests and comedians, and so it's a very important annual thing we do multiple times a year, seasonally, really. But now, of course, the COVIDiverse has forced us into virtual mode, and Chuck and I have been virtualizing for many months now, so I think we've got a rhythm going.
Yeah.
But Chuck, okay, you're wearing a T-shirt. Now you got to explain the T-shirt because it's in code. Have you explained it yet?
Yeah, well, no, it says NH3C now, and that's human caused climate crisis, and H and three C's. I know for somebody like you who's a scientist, it's probably some molecular composition as well. But for us stupid people, it's human caused climate crisis, H and three C's, and the reason is trying to put a name to it that means something. And so I've been active in the climate space now for a couple of years, trying to.
Yes, I'm very impressed by that, Chuck. I mean, I only learned about this sort of after the fact. So I'm very proud of you that you were doing this and you didn't tell me. You just went out there and did it.
Yeah, I just wanted to get involved and do my part. However, I have to say it's my association with StarTalk. We would often have on scientists, and a lot of people I'm going to reveal. So when we have scientists on, I often will read their work. And the reason is I don't want to be the idiot in the room. I could see you're a trained scientist and you're talking to trained scientists. You guys have a shorthand, you know how to talk to one another. And I don't want to be the guy sitting there going, this might be funny. So I want to know.
So Chuck, there's an old saying.
What?
All right. And I first heard this from Michael Dell, actually, founder of Dell Computers. Okay. It was, if you're the smartest person in the room, change rooms.
There you go. I love that. Ooh,
Okay.
I'm keeping that. Yeah, well, that's the deal. So yeah, so I started reading up a lot of research on this, and it's horrifying. It was horrifying. It horrified me, and I had to do something. So I started a campaign called It's Real, and it's a communication campaign to get young people to become actionists, take action. Everybody should do something. That's my whole goal. Just do your part. It's an all hands on deck issue, and everybody can do something. If we all do something, that means we're all thinking about it. If we're all thinking about it, that means we're all looking for a solution. And when you talk about, there's citizen science, but citizen solution.
Yeah, citizen solutions, a whole nother.
Whole nother. So that's what we're looking for.
Did you also announce that this is Climate Week in New York City?
I did not, and I should have. So it's
Climate Week. That's why we're doing it here and now, live on Facebook and YouTube. And of course, this is a collaboration with PocketLab. They've become our recent very good friends in this space. And so I think it's time to bring in our first guest.
Who would that be?
This is some. Oh, by the way, at the end of this program, there's going to be a Q&A, so stick around. That's usually the most vibrant part of the StarTalk Lives, as anyone who has seen us in theaters knows. So definitely stick around, and we'll be soliciting your questions in the live feeds from both Facebook and YouTube. And we'll be pumping them in to our exchange. So let's do this. Yeah. Okay, so first, a climate scientist, Catherine Hayhoe. She's been on StarTalk before, because this is not a topic we haven't addressed. And she's the director of the Texas Tech University Climate Center, professor of political science, and a UN champion of the Earth. I have to find out what that precisely means. And you said you've heard her TED Talk, is that right?
Absolutely, yeah. UN.
Well, let's bring her on.
Yeah, go ahead. Yes. Hi.
There she goes, Catherine. Hello.
Hey.
Okay, you get the award for least interesting backdrop. Just want you to know.
It's very deliberate.
All right, so could you put us on a...
that Catherine actually looks like she's calling in from a passport photo.
Well, I am Canadian.
Nice. So just put us all on the same page when scientists speak of climate change. Just put us on the same page there. What do we mean when we say climate change?
We mean the change in the long-term average conditions of the planet. So our brains are wired to remember weather, a hot day, a snowy day, a crazy storm. That's like a single tree. Climate is like the forest. It's the average of weather over at least 20 to 30 years. And that's what's changing today. And that's why we can still have hot weather and cold weather, even while the entire planet is warming.
Very cool. I'm hoping Neil is Neil playing like he's stuck? Nope, he's actually stuck. There he is. He's back.
Yes.
Okay, I dropped out there for a sec. So hold on. Are we all still there?
Yep, we're here.
We see
you. Okay, sorry.
And we're seeing you.
Yeah. So when did global warming change to climate change? When did that happen, and why?
We scientists have always called it climate change. Global warming is more of a popular term. Global warming is a symptom of climate change. It's like you're running a fever, but the disease you have is not the fever. The fever is just the symptom. So the disease is climate change, and we're seeing an increase in the average temperature of the planet, but we're also seeing a lot of other things. Things are changing in the places where we live. We see wildfires are burning greater and greater area. We see hurricanes are getting bigger and stronger. We see that heavy rain events are getting more frequent and heat waves are getting more intense. And so personally, if I'm going to call it something, I usually call it global weirding.
Very nice.
Okay. That sounds like a new dance or something.
Yeah, we should have gone with that. Should have gone with that from the beginning. Would have definitely got a lot more people involved.
And so is there some climate change? People always want to blame today's weather on a climate change. So how do you advise people to think about weather versus climate in terms of what you're going to blame the anthropogenic factors on?
So weather is kind of like your mood, and climate is like your personality. You can be in a good mood or a bad mood, but long term, you're a certain type of person. At the same time, though, we know that climate change is affecting our weather, and here's how. So imagine you have a pair of dice, and you always have a chance of rolling a double six. That's an extreme weather event. But decade by decade, as the planet warms, it's as if it's sneaking in and taking another one of those sixes, another number and turning it into a six, and then another one and turning it into a seven. And so pretty soon you're rolling all kinds of double sixes and even some sevens like you never used to before. And you're like, what is going on? That's climate change.
And that is
Wait, but on your stereo system, can you turn it up to 11 though? That's really what people know.
So, in the case of climate change, yes, you can.
Yes, okay, because it is odd when people say we haven't had floods this high since 1936. Well, you had floods that high in 1936 when no one was talking about climate change. So if the comparison to the highs today are always indexed to something long ago, what you're really saying is it's not that it's high specifically, but that we're having a lot of them. And like you said, someone is preloading the dice, so that the double sixes is no longer rare, it's becoming common.
Yeah, another way to think about it is like a baseball player. They hit the occasional home run and then they went on steroids and they started to hit a lot more home runs. Okay. So it wasn't that a home run was unprecedented, it's just that their statistics changed. And that's what's happening with climate change.
Gotcha.
And tell me about the Paris Accord, the Paris Agreement. You know, we get snippets of it. You know, in the United States, it's, are we part of it? Or are we not? We change leadership, and then someone undoes it. So where was it? Where has it been? Where was it? And where is it now? And what's our relationship to it?
Yes. So I was there. I was in Paris when this all happened. And what happened was almost every country in the entire world got together and agreed to limit global temperature change to at least 2 degrees Celsius, and if possible, 1.5. And just as a benchmark, we're already at 1 degree today. So that's where we were. And then pretty much every country in the world signed on. And then President Trump announced that he would be withdrawing the US from the agreement. But he can't officially do it until just before the election in November. So it hasn't actually happened yet. And if he does withdraw the US, they can go back in after just a couple more weeks. But here's the thing. It isn't just about federal government solving this problem. It is about organizations like cities and states, corporations, universities, tribal nations, religious denominations. And so they've all gotten together in the US, and organizations that represent almost half of US emissions have agreed that they're still in on the Paris Agreement. So it's not a 0 or 1. We're already, half of us are committed to be there. We just need the other half to come along. And for that, we need the federal government. But it isn't just the US. If you look globally at all the commitments all the countries have made, that only adds up to 3 degrees. We haven't got enough yet to get down to 2. It's kind of like a potluck dinner, and everybody's supposed to bring enough to feed everybody. Well, there isn't enough food on the table yet. So far, we're only going to hold global temperature to 3 degrees, not 2 degrees. So we don't just need the US, we need more from almost everyone else.
Yeah, but Catherine, in any given day, especially in dry climates, the temperature swings 20, 30, 40 degrees from mid-afternoon to just before sunrise. And so what can you tell people for them to be concerned about a mere 2-degree rise in the average?
I hear exactly what you're saying. And I've actually thought about how to explain this. And here's what I would say. The temperature of the planet is as stable as that of the human body. So if you add up all of the temperature around the whole world, it could be really cold one place, it could be really warm the other. But at the scale of the planet, it's as stable as the human body. And our human body temperature, 98 degrees, that's pretty warm. But if our body temperature goes up 1 degree Fahrenheit, or if it goes up almost 2 degrees Fahrenheit, which is 1 degree Celsius.
Somebody stuck a thermometer in you and you're laying up in bed.
Exactly. And that's why this matters. The planet is running a fever.
So what we need is a giant thermometer that we can stick in Australia and basically constantly monitor the planet.
Why Australia? Because that's the bottom. Chuck, where are you going with this? Chuck.
I'm just saying.
Rude.
Listen, I'm scarred from my childhood, okay? They didn't have those things you just point at your forehead when I was a kid.
You could at least have said the South Pole, okay? I mean, there's a lot of ways you could have gotten around that rather than invoking an entire continent and nation.
Yes.
Yeah.
And actually, let me tell you something really cool. The very first person to collect weather station data, because we do use weather stations all around the world, the very first person to collect all that data and show that the planet was warming was a British engineer called Guy Callendar in 1938.
Wow. And he sounds like a game show host. That's very cool. I'm Guy Callendar.
All right, so why? All right, so tell me precisely what is warming the planet. Okay, let me be more precise than that. We know greenhouse gases trap solar energy, and it remains in the atmosphere, and the temperature goes up. What are the sources of this excess excess carbon dioxide greenhouse gases?
Yes. So first of all, as you know, Neil, our planet already has a natural blanket of heat trapping gases that keeps our planet the perfect temperature for life. We'd be a frozen ball of ice if we didn't have this natural blanket. So what's the problem? The problem,
by the way, in fact, in my field, we call it snowball Earth.
Yes. Exactly.
times when the right amount of greenhouse was not happening.
No, it wasn't. So we're kind of like Goldilocks. We don't want too much of it because then we'd be like Venus. We don't want too little of it because then we'd be the snowball Earth. So the sun's energy actually goes mostly through this blanket, sort of like a window. The Earth heats up, the Earth gives off infrared or heat energy, and the blanket traps the heat energy, just like a blanket traps our body heat at night. Same way. So what's the problem? The problem is we are wrapping an extra blanket around the planet that it doesn't need. It's like somebody is sneaking into your room at night, which is sort of creepy when you think about it, and putting an extra blanket on you, and you wake up sweating.
No,
and
that's
you're
someone
like,
who loves you who puts on an extra blanket.
My grandma would always.
Grandma coming in with the crocheted blanket. Yes.
Yes, we had central heating in Canada, but she was convinced it didn't work. So she always came in every night with a blanket when I was at her house. So where is this blanket coming from? About three quarters of it, 75%, is coming from digging up and burning fossil fuels. 75%. 25% of it is coming from land use change and agriculture, specifically deforestation and animal agriculture. Because
so deforestation, because plants take in carbon dioxide and they build themselves off it and give off oxygen. You take away plants, you're removing a sink or an absorbing factor in the carbon dioxide. That's correct?
Yes, but also when you burn them, it releases the carbon in the trees into the atmosphere too. So it's a double whammy.
Mm-hmm. Okay, but if you have a tree that had carbon dioxide that it took out of the air, and then you burn the tree, it puts it back in. Isn't that neutral?
It is, but if you're deforesting area and you're not putting the trees back again.
So now the tree is no longer scrubbing the atmosphere of carbon dioxide.
Yes.
All right.
So that's why growing up in Canada, if you want to earn a lot of money in the summer to pay for university, you would go tree planting. Because some countries like Bhutan and like Canada, they tree plant like fiends. And what they're doing is they're cutting down the trees, but then they're replacing them. So the net impact on carbon is neutral. But what's happening is due to all the wildfires and due to all of the pests and beetles that are eating the trees, even in Canada, the forests have been a net source of carbon the last decade or more rather than a net sink.
Wait, you can't just throw in beetles out of nowhere. Beetles and insects. How does climate change affect our insect population?
You meant insects. I thought you were talking about the beetles.
I was. These beetles.
I do not want to speak to whether the beetles perform incest or not, but they are insects.
Insects, yes. Okay.
Yes. Fine. And what is happening is there are beetles that eat trees, and cold winters kill them off. So if they get killed off in the cold winter, you only have one generation of beetles every year. But if you have a really warm winter, it doesn't kill them off. So you have baby, parents, grandparents, and great-grandparent beetles eating the trees, and they eat millions of acres of trees. And so then when a wildfire starts, all of the trees are dried up and they can burn up.
Oh, because they eat them, they kill them, and then
they become dry and Britain, and they actually become an accelerant at that point.
Yeah, a Kindle for it. The original meaning of the word Kindle, I think. Yeah,
not a tablet.
Also, Tinder. That's another word.
Yeah, and Tinder, right? But they all had previous meanings before the internet. But
it sounds like all of the problems that we're discussing here are self-exacerbating. The one problem becomes a domino to exacerbate another problem, which becomes this vicious circle. So it's a spiral downwards. It's that's That's very scary.
So you're talking about a sort of a self-feeding loop.
Yeah.
Right? Yeah.
A self-amplifying feedback. We don't want to call it a positive feedback because that sounds good, right? Like, I'll give you positive feedback. It's like, you did a great job. So we tend to call it self-amplifying or even a vicious cycle. And the worst vicious cycles are in the Arctic.
Yeah.
All right. So what do you plan to do about this? No,
yes, you, Catherine.
Catherine,
what the hell is your problem, Catherine?
Well,
you are the UN hero of the planet.
You are one.
Right.
That's what I was doing last year.
What does that even mean? Wait, stop. What does it mean to be a UN hero? What does that mean?
Well, I showed up and I was expecting the cape.
So you showed up. That's all it took.
No, I was expecting the cape and the superpowers, and I did not get them. And I'm severely disappointed because I thought the whole deal was you got those and then you saved the planet, right?
Gotcha.
I mean, Captain Marvel?
Yeah. You don't have superpowers.
You're basically the Canadian Captain Marvel. So
I would like to be. And in fact, actually, I have a fantastic colleague who's based in New York. Her name is also Catherine, but she goes by Kate, and her last name is even Marvel. So I would be totally
happy.
You
know Kate Marvel. Yeah.
Yes. I know Kate well. I would be happy if she got the Kate, too.
We've had her several times on StarTalk. But let's ask. So we want to do something about it because we don't want to warm the Earth outside of our understandings of our civilization or capacity of civilization to accommodate it. So do we all become vegan? Do we stop having kids? Do we what are some easy things, fast things, because we're all lazy, so what's the simplest easy thing to do?
Well, that is the number one question I started to get when I started to talk to people about climate change. And I was like, well, I'm a scientist. I don't fix this problem. I tell you how bad it is. But that's not satisfying because you can't have somebody tell you there's a problem and not tell you how to fix it. So I've thought about this for a really long time because we could each do everything we could. And that would just fix a fraction of the problem, just a fraction. 90 companies have produced 2/3 of heat trapping gas emissions since the dawn of the industrial era.
Okay.
But,
okay. You want to pull the plug on 90 companies?
Not just that. We need system-wide change, and some of those companies are already starting to change thanks to pressure. Some of them might not change, and they're going to have to go the way of the horses and buggies. But we need system-wide change. But a system is made up of individuals, so that's why
we got to take a quick break. Okay. But when we come back in just moments, Catherine, I want you to pursue what it is that we need to do about climate change and the ways climate change is influencing our behavior, the way it should or isn't or can influence our behavior. So this is StarTalk Live on Facebook and YouTube. End of segment 1. Back to segment 2. I just see what he did there.
God, that was such a long break.
Welcome to segment 2 of StarTalk Live. We are in the virtual coronaverse right now, and this whole subject is on climate change. And I know a little bit about climate change, but not as much as any expert we would bring to the table, such as who do we have? We have more coming. Who else do we have coming in on this segment, Chuck?
Dr. Peter Mahaffey will be here as well.
Okay. And so we've got Catherine Hayhoe. Thank you again, Catherine. And your Canadian accent is charming, let me just say. I know you're trying to hide it, but you can't. It's there for all of us to hear. But tell me something. How realistic is it to just simply change everybody's behavior?
Well, the first thing we have to change is not our behavior. The first thing we have to change is the way we think about the problem. Because it turns out, even though the headlines are all about people who reject science, when you actually look at the polling data, our real problem is that we don't think it matters to us and we don't think we can fix it. So that is why, go ahead.
No. I'm That's very nice of you to anticipate what I'm going to say, but you have the floor. You keep talking.
All right. So that is why I have become absolutely convinced, after years and years of working in this, that the number one thing anybody can do is use their voice to talk about why it matters to us in the places where we live in ways that matter to us as people, and what we can do to fix it, which includes individual solutions like step on the carbon scale, measure your carbon footprint, figure out things you can do, but talk about how big corporations are going carbon neutral, like Microsoft and even Walmart and Apple. Talk about how cities are cutting their carbon emissions and meeting the Paris Agreement targets It's like the city of Houston, where all of the big oil and gas companies live. Talk about how clean energy is revolutionizing the lives of poor people who don't have access to affordable electricity. Talk about how carbon farming puts carbon back in the soil, increases our soil health and our yields, and helps farmers be part of the solution. Use your voice to advocate for change at your school, at your place of work, at your organization, at your city, in your family. Using our voice is the most powerful thing we can do.
So that's hopeful. And that's what we're doing here, right? With this StarTalk Live, featuring your voice, the Canadian Captain Marvel, as you are. Tell us the fact that fewer people are traveling now, the coronavirus lockdown, what has that done to the climate?
So it has reduced our emissions. In April, global carbon emissions dropped by 17% around the whole world, and they dropped by 25% earlier in China as the lockdown happened there first. And they're still a little bit lower than average because people aren't flying. That's great news. But as the lockdown passes, they're just starting to go right back up to where they were.
Oh, well, you don't think there's some habits that we've accumulated? Because it's way easier to do this virtually than everybody get up and get in a car and go to a theater. I mean, do you think there'll be some lingering bits of this that we keep?
I think that there definitely will be. But the bulk of it was industry, not you and I flying or traveling. That's only about 3% of total emissions. Here's the positive thing, though. To meet the Paris target, which we were talking about before, we have to reduce our global carbon emissions about 45% by 2030. And that sounded like an almost impossible goal last year. Well, you know what? We got almost halfway there in 3 weeks in April.
Right.
Okay. Yeah. Okay. So that's it's, as they say in math, it's an existence proof. It's, right. Oh my gosh, you think we can't do it? We kind of already did.
Yeah, we had a proof of concept.
Exactly. And
but emissions went back up again. So we just have to realize that we can do it. We can bring them back down permanently, not temporarily.
So, I mean, go ahead.
No, go on, Chuck. Go on.
Yeah, I was going to say, so with respect to what you were talking about with all of us using our voice, which I think is excellent. I think the Yale Climate Communication Study said that somewhere around 54% of people basically say they don't talk about it at all. They just don't even ever talk about it. So it's extremely powerful. But don't you also think that if we are doing something personally, that makes you vested in the problem? And being vested in the problem makes you want to see other people take action. And it also makes you want to hold corporations and leaders, authorities, accountable.
Yes, absolutely. So the social science has found that our sense of efficacy, in other words, if we feel empowered to act, that has a tremendous impact. And also even our sense of righteous anger. Look, I'm doing everything I can, and look at you, you're doing nothing.
I forgot such a term exists, righteous anger. That's like good trouble. You know, it's one of those kind of things.
I hear it every Saturday when I'm laying on the couch.
What? Get out and mow the lawn.
Exactly. Look, I'm doing everything I can. I got to do everything around here. I'm doing everything. Go ahead.
Let's talk Chuck down off the ledge right there. So, Catherine, tell me about the wildfires that devastated Australia recently, and of course are doing so much damage in California.
So wildfires are one of these things we talked about where we're loading the dice. We've always had wildfires. In the US, most of them are human ignition. Most are accidental, not arson, just to be clear. And up in Canada and Alaska, they're mostly lightning.
Just human ignition is not always malevolent, is what you're saying.
No, only 7% of the big fires in California were actual deliberate arson. Most of them were, as we now know, gender reveal pyrotechnics gone wrong, or people dumping burning trash into dry brush, or just having something plugged in the shed that shorted out and started the shed on fire, or power lines sparking. That's what starts most of the wildfires.
Okay, right. Didn't know that. So can you trace a thread from the wildfires to climate change?
Absolutely. Once they start, they're burning greater area. And the reason why they're burning greater area is because the vegetation is dried out. The difference is, imagine you throw a match on a pile of pretty green wood. What happens? Then imagine you throw the same size match on a pile of bone dry kindling. What happens? A conflagration happens. That's the difference between climate change versus not climate change.
Wow. All right. So I'm still trying to figure something out here. If you just say things dried out. Climate change, they dried out. Aren't there places that are getting more rain than ever before? You know, tell that to a place that just had a huge flood. So we are simultaneously, as a scientific community, saying, yep, it's dry over there, that's climate change. Yep, it's wet over there, that's climate change. And so people, I don't think they have a sense of some directed phenomenon that is itself increasing. So how do you reconcile that?
You're absolutely right. And the point of connection, the invisible point of connection, is the fact that warmer
It's
air...
invisible?
Invisible.
I need special glasses to see it. Okay.
No, just physics. Just physics.
But scientists said, there's this invisible thing. You just got to believe me.
Right. No, we can measure it. We can measure it. We just can't see it.
Okay.
It's the fact that the warmer the atmosphere, the more water vapor it can hold. So in other words, the warmer it gets, the more it dries out our soils, and in dry areas like California, our vegetation. But when a storm comes along, there's more water vapor up there for that storm to pick up and dump on us. So in a place that gets lots of storms, they're getting a lot of heavy rainfall events. In a place where they don't get storms, all that water is evaporating and it's just being transported out of the region, leaving it drier than it would before. It's the exact same mechanism in both cases.
So these are related phenomena, the
Yes.
flooding and the droughts.
Yes.
Okay. And tell me about a sea level rise, because that's anytime I'm asked about climate change, that's what I think about the most, because most of the world's great cities are on the water's edge, historically, of course, for commerce and transportation and irrigation and the like, on rivers, for example. So sea level rise, how does climate change give you that, and who gets affected first?
Mm-hmm. So remember we talked about how we're wrapping an extra blanket around the planet that's trapping more
Grandma's
heat.
doing that, yeah.
Yes. Over 90% of the heat being trapped by that blanket is going into the ocean. So when we're using thermometers to measure global air temperature, global warming, we are literally measuring the tip of the iceberg, and 93% of that iceberg is under the ocean.
Okay, just to be clear, you're talking about the heat energy, not the temperature. So if the ocean goes up by a fraction of a degree, much smaller than 2 degrees Celsius, that is an enormous amount of heat energy as a repository. Is that correct?
Exajoules.
Yes.
What's that word?
Exajoule.
What does that word mean?
It means a lot of heat.
Exajoule. Excuse me. Exa as in the metric prefix exa.
Yes.
Joules as in the unit of energy. Thank you. Okay. I thought that was a new hip word that I didn't know about. Okay.
Yes. It's what all the kids are using to vape. it's the newest vape.
Okay. So there's kilo, mega, giga, exa. These are the metric prefixes, and there you go. Okay.
Yeah, giga and peta. So
Chuck Liu, your buddy, another astrophysicist, did a calculation that I'm going to screw up, so I don't want to say it, but he did the calculation of the warming of the oceans, how much energy they are holding, and it ended up being like, I don't know, 100 atomic bombs, the equivalent of something like that.
What he did was he calculated, and I was going to verify this so that we can then go public with that number. Generally, you do that when you're scientists.
But I'm not a scientist, and you guys were arguing about it, so now I could just say it.
No, I'm just saying. So you can ask, how many atomic bombs would you have to detonate in the atmosphere to raise the temperature 2 degrees, as we have done, or we raised it 1 degree? What is that? And then, but we know atomic bombs, and everything else feels a little more sort of nebulous. So Catherine, in your business of bringing this to the public, you are just chock full of examples such as that, right? Because otherwise people can't wrap their head around the pure science typically that would otherwise be delivered.
No, we can't. We're not used to processing numbers like that, like 10 to the 21. What does that even mean? But why it matters, though, is because...
Wait, 10 to 21, that's how many gigawatts was in the flux capacitor. Everybody knows that.
Oh, my God. What is wrong with you?
10 to the 21 gigawatts.
10 to the 21 gigawatts.
Yeah, it was actually gigawatts, but they said gigawatts because it's a movie, but that's fine. Wait, so let me ask another thing, Kevin. Some decades ago, one of the News Weekly magazines, back when people read things on paper, it had a headline, Ice Age coming. Okay, so tell me about these calculations that talked about ice ages, either in the past that would be imminent, or ice ages that might have been scheduled for the future and now will be delayed. Isn't that a good thing?
Yes, because we humans don't like it too cold or too hot. We like it just right. So in celestial mechanics class, which you probably took too, we learned about the orbital cycles of the Earth's orbit around the sun and how they alter the way that the sun's energy falls on the Earth. And those are actually responsible for the ice ages, or what we scientists call the glacial maxima, and then the warm periods like we're in today. But because they are predictable, we can calculate where we are on that cycle. And here's where we are.
Oh, this is good.
Yes.
Oh, this is good. Oh, I love this part.
All right. This is the end of the mystery novel. Right here.
Here's where we are on the. Okay. Go.
All
we
right.
can take it. Bring it on.
We know that there was an ice age about 20,000 years ago. We know that it ended when a rodent went looking for an acorn and broke off a chunk of ice. No,
That's exactly what happened in the movie Ice Age. That is a documentary. Just so you know.
And you were probably there filming it, right?
I did have a cameo in Ice Age 5. Just so you know. I have a cameo in Ice Age 5. So I have to quickly tell you, one of the reviews of Ice Age 5 was, it said, "This is evidence that it's about time the franchise goes extinct." So there hasn't been an Ice Age 6.
I'm sorry.
So anyhow, back to, go. Right. Okay. So where are we on this cycle?
It was an ice age. We got warmer. Warming peaked about 6,000 to 8,000 years ago, right around the dawn of human civilization.
And agriculture even.
And agriculture, because we had the perfect climatic conditions. And then since then, temperature was very, very gradually slowing and cooling, very gradually. But agriculture and deforestation had pretty much stabilized it. So we had pretty much hit the sweet spot. And then the Industrial Revolution happened and we're going straight in the opposite direction. So the official conclusion is that the next glacial maximum would have happened in about 1,500 years, give or take a few hundred years. But in fact, we have indefinitely delayed it for not just thousands, but probably tens of thousands of years. And not only are we want to be stable, but we're not stable. We are headed in the other direction faster than any time in the history of human civilization on this planet.
So right now, we should be in a cooling period, is what you're saying.
Yes, you said.
We should be going down.
That's what she's saying. So yeah, tell that to LA when it was 120 degrees a couple of weeks ago. So what was it in Pasadena? Somewhere in the valley. So let me ask you. I leapfrogged over one of my questions, which was about sea level rise. Could you just tell me? Is it just melting of land glaciers? Is that all that's happening there?
Right. So about half of sea level rise is because warmer water takes up more space. And all of that extra heat is going into the ocean. The other half is the melting of land-based ice, not Arctic sea ice, because Arctic sea ice is already sitting on the water, like ice cubes in your glass. When the ice cubes melt, your glass doesn't overflow. But what's happening now is that sea level is rising twice as fast as when the satellite observations began 25 years ago. And that is because Greenland and Antarctica are melting much faster than they used to be. And the reason we care about it, like you said, is because 2/3 of the largest cities in the world are located within just a few feet or a meter of sea level. And about 700 million people live in the low elevation coastal zone.
So we just have to pick up cities and move them inland. And then that's all.
It's like a Superman movie. Just, it's like, hey, just buy property in Camden, New Jersey, instead of the Jersey shoreline, because that's going to be beachfront property one day.
You're talking about Superman, the movie, the original.
Was that the original movie?
Yeah, you're going way back, Chuck.
I don't know. It was Lex Luthor. That's all I remember.
Lex Luthor's in more than one of them.
Yeah,
He's a recurring.
Yeah, they're all one movie to me. They're all one movie.
So what are the first? So cities will obviously get hit, but I read about whole countries or land masses in the South Pacific or in the Western Pacific region of the world, where whole countries are just a few feet above sea level. So they'll just be gone if this continues.
Yes, and they're already trying to immigrate, but unfortunately, climate refugee is not an official designation for a refugee under the United Nations.
You work for the UN, change it.
I don't.
You're a card-carrying UN person?
They didn't give me a card. I'm telling you, no cape, no card, no superpowers.
No card, no superpower.
Big piece of glass. Big, large piece of glass. That's it. unfortunately, so New Zealand, for example, is taking a handful of people a year. They have a quota, but they're not taking nearly enough people to move the entire population. And even so, losing your country. Even if you could transport your entire family, which most people are not yet able to do, even if you could transport your whole community, you're still losing your country. And that is something that's part of you.
So suppose you live inland and you're just selfish. You say, okay, I live in the Colorado Rockies. I don't care about changing sea levels. A lot of people, I think, who feel that way. So what do you do when you confront them?
Climate change is the great threat multiplier. It takes whatever issue you're currently dealing with wherever you live and it makes it worse. So if I talk to people in Colorado, I talk about their snowpack. Warmer winters, less snow, also heavy floods in between, crazy floods.
So the snowpack, just because I'm a city guy, so let me see if I understand that. So you expect a certain amount of snow during the winter that stays up on the tops of mountains, and you're skiing and other winter sports. And then in the spring, the snow melts, and it's a supply of water down into your valley or whatever surrounds the mountain. And that balance, that ecosystem, is something that's been honed for thousands of years. Is that a fair interpretation of what you just said?
Not to mention the depletion of aquifers. You also have tourism. People go to Colorado to ski. You're not going to be able to do that. Who wants to ski on grass? And I'm black, and I know that.
It will be mud, Chuck. I've actually done that in Colorado, and it's mud.
And not to mention, well, come on, seriously. I don't know nothing about skiing. It's too damn cold, and that's all I know about skiing.
Okay, well, protect our winters. Protect our winters needs to take you skiing, and you could both talk about climate change together.
And listen,
it'll be a data point in our lives. Yes.
Yeah, I'm all happy to talk about climate change with them in the lodge, next to a fire with a brandy in my hand. Isn't climate change awful?
Right, Catherine, you got to leave us some hope here, because you're just saying we're all going to die, and what's the, and you can't just say let's keep talking. Yes, you did say that, and yes, I appreciate it and embrace it, but give me something to go into the next segment with, so that we're all not just completely bummed out.
Right now, this is what you should do. Just go, Neil, I got nothing, and I'm out. That would be the most awesome ending ever.
I am on my way to the launch pad for Elon Musk's ship to Mars. Just kidding. No, there is hope, and that's actually what I.
Right, that'd be funny, Chuck. If she's saying, "No, here's what you should do," as she's sort of backing out the back door, and then there's a spaceship waiting for her to evacuate.
See a SpaceX van picking her up.
Absolutely.
All right. I'm compelled to say just right now that Mars is, Antarctica is balmier and wetter than any place on Mars. So Mars would not really be the first place you'd think of going.
No.
I'd rather fix Earth, just so you know.
I completely agree with you. In fact, one of the previous times we saw each other was at the Starmus Festival in
I'd forgotten about that.
Norway.
Thank you. Yeah, up in Norway, in a city I can't pronounce, but it was in Norway.
Trondheim.
Yes. Trondheim. Thank you.
Trondheim,
Thank you.
yeah.
Right,
and so Stephen Hawking gave one of his very last talks there before he passed away. And of course, he spoke a lot about the risks and dangers of climate change. But then he said, we might just have to terraform Mars. And I'm sitting there thinking, are you insane? Because there is no way we have time to terraform Mars and get large numbers of people there before climate change overtakes our civilization.
No, you just you just terraform it fast.
Right.
It would be a lot easier to fix climate change. So,
you know what my rebuttal is to that?
Oh, do tell me.
It's a rebuttal.
Okay.
I think it's a strong rebuttal. And Chuck, I want to get you
dumbass.
That's probably Neil's rebuttal.
Is that the rebuttal? Hey, Stephen Hawking, you dumbass.
That is not. No, here it is, because I live in a real world, a practical world, and I like practical solutions to practical problems, not imagined solutions that we wish were true. Consider that if we had the power of geoengineering to turn Mars into Earth, then we have the power of geoengineering to turn Earth back into Earth. Just chew on that.
Yeah, that's a very good point. And I would say, so
therefore, let's terraform Mars and ship 1 billion people there. No, terraform Earth. But if you can do that to Mars, you can do it to Earth.
Without side effects.
That's so wrong.
Yeah. And you can't without side effects. That's the thing. It's like giving everybody a vaccine for coronavirus that hasn't even gone through stage 2 testing. That's what geoengineering the planet is like today.
Well, at the moment. But I think it has a fertile future for saving us from ourselves. And because often engineering problems are the solution rather than changing the behavior of 1 billion people. I mean, that's hard to do.
Well, here's the hope. I want to leave you with hope. And then you need to talk with Peter because he's got lots of good stuff to say.
Yes. We have another guest coming in the third segment. Yes.
The hope is this, and this is what I study. I study the future, and I look at the different choices that we as a civilization make. And I can tell you that there is a world of difference between a scenario where we just keep on using fossil fuels the way we have for 300 years versus a scenario where we transition to clean energy. Number one, we are much more efficient. Half of US carbon emissions, we could get rid of them just by being more efficient and saving money. And then also some lifestyle choices too, which just makes sense. And let me tell you this, when a new iPhone comes out, do people say, oh, you really should get it? You have to get it. It's better for you if you get it. No, everybody lines up to get it because it is better. So technology does have a place, and people are lining up to get things like electric cars and solar panels and cool things. And we've got solar paint and solar roads and solar bike paths and wind turbines and mini wind turbines. But we've also got efficiency that saves money. We've got things that actually have short-term benefits as well as long-term ones. And short-term benefits can change people's minds. And so our choices absolutely matter today more than ever, and we can make a difference. And one person truly can be that agent of change.
Wow.
Okay, Chuck, since you just say we have to all stop having kids and become vegans, you just said that.
I am all about that.
Stop.
You do not have to tell me not to have any children. Believe me, I am so on that train. I'm the
Chuck has 3 kids, by the way.
I'm the conductor of that train.
No. So Catherine, your comments are wise and sage, and so there is some hope, even if it's not unfolding on the time scale that we seek. Perhaps it'll maybe we need a few more disasters to make people sit up a little higher in their chairs, perhaps, because we tend to be better at reacting to a problem than preventing one in advance, I think, the history of American behavior in the world. So, but okay, because you're on the front lines. And if you tell us to have hope, I don't know who else to believe but you.
Active hope. Not just passive, it'll all turn out okay in the end, because it won't if that's the type of hope we have. We have to have active, realistic hope.
None of that Jesse Jackson hope. You know?
Keep hope alive.
Keep hope alive. I'll make a rhyme, and then it'll be time to keep hope alive. Yeah. None of that. None of that.
So,
we want
so
real
what you're
hope.
saying, Catherine, is because I don't like the word hope because it's what you express when you confess that you're not in control. Oh, I just hope. But so the fact that you've now put a nuance on it, this passive hope, which is what I just described, and active hope. I have hope that this will change, and I'm doing something to enable that.
Yes.
We will end segment 2 on that positive thought by Catherine. Catherine, it's a delight to have you again on StarTalk. We will continue to reach for you because this has not ended. And when you do get a card carrying UN ID, tell us. Then we can hold you to it with whatever UN says. You go back and read in the Riot Act.
Or Catherine, don't worry. Just email me. I know some people that can make you one. Yeah.
Oh, to make her. Chuck, you got people like that? I got different kind of people. You got people. All right, Catherine, thanks for joining StarTalk Live.
Thank you for having me. I'm going to visit you all on Facebook and drop a few links into the chat if people want more.
Definitely do so. All right. So let's go right into segment 3. This is StarTalk Live. We're talking about the science of climate, the sociology of people's reaction to climate change, all of the above. And we're in collaboration with PocketLab, who helps us bring this to you live on Facebook and Where else are we streaming? Facebook and
YouTube.
Of course. YouTube, of course. So coming into this segment, we're going to talk about climate chemistry and citizen science. And who's going to join us for that? Because I know a little bit, but not enough like the experts know. Let's bring in Peter Mahaffey. Peter, welcome back to StarTalk.
It's fabulous to be here, Neil. Chuck,
excellent. You're professor of chemistry at King's University in Alberta, Canada.
That's right.
Co-director of the King Center for Visualization and Science. That's right. And with a special focus on climate change, science, and awareness. You're the guy. If all this fails, it's your fault. If the attempt to change the world, because that's your title. That's on your business card.
Well, people have been blaming chemists for a long time, Neil. So lay it on.
So through the lens of a chemist, how do you think about and study climate change?
Yeah, that's a great question. Your audience is probably sitting there thinking, you're bringing a chemist on. What do chemists do? Well, they bring us toxic substances and pollutants and smoke coming out of exhausts. But I want to...
No, Peter, some of my best friends are made of chemicals. Okay, I don't know about you, but that's true for me. Yeah.
Yeah, I want to plant a different image in the minds of your listeners and viewers. And that's, I think of chemists as caretakers or stewards of matter and energy. And think about climate and climate change. Climate is regulated by matter and energy flowing through our atmosphere, cryosphere, oceans, and land. And chemists transform and analyze substances. We understand the flow of energy and chemical reactions and processes. So even though chemists don't pay nearly enough attention to that, climate change is right in our wheelhouse. And we need to both talk about it a lot more, as Catherine Hayhoe was saying. We also need to do a lot more about it. Let me give you an example. Everybody knows about carbon dioxide, right? Carbon dioxide formed from fossil fuels that were laid down maybe hundreds of millions of years ago. They've been there, and now in the last 250 years, we've extracted them at dramatic rates, and we're burning them, we're making CO2. Simple combustion reaction. And that's changing the energy of our planet in a short period of time. So that's chemistry that we understand and control, and it makes our life a lot better. But there's other chemistry too. There's greenhouse gases like methane and nitrous oxide and fluorinated gases. And physicists pay attention to isotopes in Antarctic ice that tell us what the temperature was a long time ago. And the best of all of this is that knowledge is now followed by the things that chemistry is doing at the forefront to develop new technologies to tackle climate change.
Okay, that means you can help us here. You're not just some chemist in a lab. Even though you know what's going on, you can actually be inventive and innovative to help this cause.
That's right. It's all about understanding so that we can do something about it. And then it's helping to provide the materials and reactions and new ways of thinking about transforming materials in order to mitigate climate change. And, there's new carriers for fuel, hydrogen and ammonia. There's fuel cells. There's the materials for solar cells and wind turbines. Chemists are working hard to create new ways of fixing nitrogen to feed the world.
Chuck, when Peter started talking, when he said, we command all of matter and energy. That was like the beginning of a superhero movie.
Well, basically, yeah.
He's somebody's superhero nemesis in the making here.
If you think about it, chemist or Thanos. I mean, that's basically what they are. Don't let Peter snap at you.
I love the metaphor, Neil, of caretakers or stewards, right? We have these powerful tools, and we need to learn how to use them in a way that's green and sustainable and helps to build a better future for people and for our planet.
So what do you think in terms of, as you said, chemical companies may be seen as part of the problem, and we've had this conversation where you say chemical companies make what people demand. So, we're part of that problem too, but can they be part of the solution, and how would that be? Is there a...
What would that look like?
Yeah, what would that look like if we were to use chemistry as a way out?
Yeah, absolutely. And there's a huge change happening.
Wait, can I just butt in for a sec? Since it's not often I'm in arm's reach of a chemist, just before you answer that question.
I'll back off a little bit.
Don't let him near your neck, Peter. Don't let him near your neck.
Could you just list for me the greenhouse gases that are in the atmosphere and that exist, so that I have a full understanding? Because when you come at us and say, here's what we can do to fix this or that, presumably some solutions are best for some greenhouse gases relative to others. So just give me that quick inventory.
Yeah, for sure. The only one that gets any airplay is carbon dioxide, right? And it's all about CO2. And that's for good reason. It's the most important greenhouse gas, and it's something that we can do a lot about, and we're doing a lot about. But right behind that, Neil, are methane gas, CH4. There's nitrous oxide, laughing gas. Who would have thought that's a major contributor to climate change? And then
where does that come from?
And
So-
why can't I get more of that in my life?
it's
and you talk about methane. This is like cow flatulence, right?
That's right. That's a contributor, methane. One of the contributors are agriculture, including intensive agriculture. But methane comes from anaerobic fermentation, the stuff that happens in rice fields and paddies. It comes from landfills.
Termites too. Termites. Yeah.
Termites produce
Yeah.
large amounts of methane, oil and gas operations that aren't
My
really tightly
Uncle
controlled.
Daryl. Uncle
And
Daryl.
it's-
Uncle Daryl.
Uncle Daryl, big
You know,
contributor.
It's
He's a
present,
big source of methane on the couch.
Big source.
it's present at a lot lower concentrations than carbon dioxide, but it's about at least 30 to 70 times as powerful a greenhouse gas as carbon dioxide is,
Molecule for molecule.
molecule per molecule. And so it's a good thing there isn't as much of it in our atmosphere. But then you go to the third one on the list, which is laughing gas. And here you're thinking, oh, dentists, right? They're making all of their patients relaxed. And
I knew it. The dentists are the source of all our problems.
The other place that you might think about with laughing gas is if you go to the store and you get some whipping cream, and that little spurt that you hear on your pump when you put it on your pumpkin pie, that's laughing gas. But the real sources of it, and they're
I'm not giving up my whipped cream. I'm sorry.
well, it's not
flood the world. Take us into it.
it's not a big contributor, but it's
Okay, no.
growing the pumpkins for your pumpkin pie that's the problem, Neil, because it's when we over apply fertilizers and bacteria in the soil end up doing nitrification and denitrification processes that turn all of that extra ammonia and nitrate urea fertilizers into laughing gas. And it
So it's
lasts,
agriculture.
agriculture is a big contributor, and it lasts for it's about 300 times the global warming potential of carbon dioxide molecule per molecule, and nothing happens to it in the atmosphere. It doesn't dissolve in water. It doesn't break down in chemical reactions. So it's a big player. And then the third one, the last one on that list behind carbon dioxide, are the fluorinated gases, things like the CFCs and so on. You put all three of those together, and they add up to about 2/3 to 3/4 of the change that's happened to our planet's radiation balance since the Industrial Revolution. They're
So
really
you said CFCs as a chemist. Okay, you're fluent, but for everybody else, those are the
Sure.
chlorofluorocarbons, correct?
So it's CFCs. These are molecules that are made of carbon atoms and fluorine and chlorine atoms only, and then they've been replaced with ones that aren't as damaging to the ozone layer. But there's other fluorinated compounds too, where we put fluorine atoms on carbon. And whenever you do that, they last a long time in the atmosphere, and they absorb a huge amount of infrared radiation that would otherwise escape our planet and go into space.
So can I ask you, when you talk about methane, which is far more powerful than carbon dioxide, pardon me, when we talk about losing the permafrost and you talk about the melting of glaciers, that means that we're going to have a crap load more of methane in the atmosphere, right?
Yeah,
Well, tell me about the permafrost. Let's hear that story.
So there's two places where we have a lot of methane naturally stored on our planet, and one of them, well, three places, of course, is deep underground in oil and gas fields. But we have a lot of methane stored in the permafrost up in the polar regions, and some of it's pretty deep down. And then we have methane stored in molecules that are called clathrate hydrates. They're kind of locked in cages of water molecules off of ocean shelves. And when we get to the polar regions like the Arctic, and we start seeing climate change happening, and if we get a change in temperature of a couple of degrees average around the planet, that translates into 8 to 10 degrees Celsius increase at the poles. And what happens? We start getting what Catherine talked about, a positive feedback loop. And positive doesn't mean a good thing. That the temperature warms up. It doesn't take much energy to release that methane gas. And then we get one of these feedback loops going where the methane gas, powerful greenhouse gas, causes more local warming, causes more permafrost melting. And that's probably been one of the phenomena that has happened at other times in our Earth's history when we've gone through mass extinctions. We've maybe had a meteor hit the planet and released a lot of methane from clathrate hydrates.
Chuck, did you hear how casually he said that?
Yeah, exactly.
So, yeah, it's kind of happened in the past.
Our other mass extinctions. Those other things that happen.
Those things.
One time. There was a time when a meteor hit the planet. That didn't go so well.
Yeah, it's just another time. It's all right.
We used to have these things called dinosaurs. We might join them. We might join them. Who knows?
Hey, but that's what makes this climate crisis so serious, right? The effect that it has on biodiversity, the effect that it has on human life, but also our whole planet's life. And we're risking entering another mass extinction because we can't seem to manage that problem of greenhouse gases.
So what's the biggest challenge, and given your chemical expertise, what are the biggest opportunities that you see in front of us to mitigate climate change?
Yeah. So the two big challenges are that the climate crisis is so serious and it's on such an urgent timeline that we feel inadequate as humans and we become paralyzed. And I think another equally big challenge is that politics has hijacked the climate conversation in really unfortunate ways. So, carbon dioxide molecules in the atmosphere don't vote conservative or liberal or Republican or Democrat. They don't respect national boundaries. And yet the gases that we emit in North America, for instance, affect life in really profound ways for people in other parts of the world who don't emit many greenhouse gases. So we've got to find ways to understand each other, to move beyond our nationalist agendas and work together to become caretakers of the planet.
Okay, so it's easy to say.
Yeah.
How are you going to make it happen?
Yeah, well, there's a little visualization that maybe Lindsay can pop up on the screen. One of the things we've done at our King Center for Visualization and Science is to work over the last 2 years to create an interactive learning resource. It's called Design Our Climate. And it's something that your users can go to. It's going to encourage them to envision the future, to design future emission scenarios by making informed choices about electricity, transportation, land use, building materials. And what do you find when you do that? First of all, that if you use currently available technologies, you can get to our target of 1.5 degrees Celsius. It's tough. It requires fundamental changes. But the other thing you find is there's no silver bullet. There's not one new magic technology that we can impose that's going to make it happen. I like to say there's silver buckshot. There's a whole bunch of things that we can do, and we can do them together, and they will make a difference. So yeah, that's a resource that I think your listeners might find pretty helpful.
I'd never heard a firearms analogy uttered by a Canadian before.
Yeah, makes sense. It's like silver, but all we have to do now is shoot climate crisis in the face. That's what we have to do.
So, what do you know about the Blue Sky Zero citizen science initiative? What is that?
Yeah, that's fantastic. This is an initiative of PocketLab, who's co-sponsoring this event. And PocketLab makes a bunch of sensors, air sensors, water sensors, instruments for citizen science. And my team at the Visualization Center up in Edmonton partnered with PocketLab over the last year. And we've been helping launch a program called Blue Sky Zero, get a bunch of air quality sensors in the hands of citizens from around the world, and then see if they can measure air quality during the shutdown. And then as we emerge from the shutdown, can we actually measure significant changes in air pollutants? And so that pilot was really successful. It showed us that we can do it. We can get data back to scientists who can begin to make sense of it. And now the challenge is, can we roll out some citizen science initiatives on a much bigger scale to help all sorts of people understand and feel like they can own their understanding for some of these big challenges?
Wait, Peter, I have a better idea. Figure out a way, go back to your chemistry lab now, figure out a way how to color tag carbon dioxide molecules so that anytime you drive your car, you'll see it coming out into the air. And because it's all invisible, all of it.
Yeah.
And if people can't see it, they don't think it's there, and then it's not an active thought. When you see plumes of soot coming out of trucks and cars, we fixed it. Took a while, but we fixed that. All right. And so can't you tag molecules and make them visible, or at least temporarily?
The only problem with that is it'll become a fashion statement. We're such idiots that you'll see people just be like, "Oh yeah, I went with the green."
The green.
I went with the green.
What with my outfit?
Right.
Or if you color coded methane, you would know who dealt it.
Now that I'm in favor of.
Yeah. Hey, what are you going to say if I tell you that we can do that already? But it's not what you're thinking. So, the big problem we have with these greenhouse gases is that you walk outside and you can see some air pollutants, right? Maybe the sky's brown or it's hazy from forest fires. But the greenhouse gases that are causing climate change are colorless. They're interacting with invisible radiation in the infrared region spectrum. So we don't understand what's going on. But if you put on the glasses of a chemist, you know what you can do? You can color them with looking at their isotopes. So some carbon atoms are carbon-12 atoms and some are carbon-13. And you know what you can do? You can actually tell whether the carbon dioxide over a city or over a nation is actually coming from industrial processes through their isotope ratios, or whether it's coming from natural sources. So yeah, it's not quite as nice as violet carbon dioxide molecules, but if you put on a mass spectrometer set of glasses, you can look at them, and that's a pretty cool tool.
Well, you know what? So
Give me one of those. A mass spectrometer.
I would love a mass spectrometer for that. But the cool thing about that is, has anyone done that from an imaging standpoint? I think it would be very powerful to show people the images of where they live in their communities, and to be able to see the air quality where they live.
Chuck, we did a little bit of that. We did a visualization of that for one of the episodes of Cosmos, where we tried to show how different the world would look if you had access to those sort of visual tools. But it's one thing to show it in with computer graphics. It's another thing for it to be real.
Yeah.
So Peter, get back to work on this now.
We're on it, and I love Chuck's idea. There's a project for this.
Yeah, absolutely. It's super cool.
So there's a planetary. I see the occasional slide come up. Did you fully explain the slides as you needed?
No, I just want 30 seconds with that slide that just popped up.
Go ahead.
Put it back up, Lindsay. So we're absolutely thrilled, Neil, to announce today on StarTalk that we're unleashing on the world a free interactive electronic resource to use to help understand what the status of our life support systems is and the extent to which human activity is threatening them. It's called the Planetary Boundaries Framework. Some of you are going to know something about it. You can
so what we see is just a frame shot, but it's actually an interactive tool.
It's a live interactive tool that went live last night at about midnight. And you can look at all 9 Earth systems. You can see how their control variables change over time. You can click on them and get a bunch of information about what you can do about them. We think it's going to be a really powerful tool to help with climate change understanding and how it's linked to all of the other Earth systems. Because climate change
it looks like an awesome teaching tool, of course.
It is, yeah.
Yes. Yeah, because then you can walk people through it, and then they become, then they can take that to others once they become sort of fluent in it.
That's right.
In what it means and where it's going to take you. So what thoughts of hope do you have for us here before we go to our Q&A?
Hope, it's got to be active hope. But what brings me hope, Neil, is 2 things. I'm really privileged to work locally in a learning community. And these days, teaching chemistry, every day when I go in, I see my students with masks and face shields on, and they're trying in the middle of all of these challenges to live out our university's vision statement, which is help to build a more just, humane, and sustainable planet. And they're doing it. Our world's in good hands with these young people. But then I also work at...
That's because they're all Canadians.
Well, they're Canadians. They're nice. They're nice, too.
Duh. That's just... that you get that for free. You didn't work to get that.
We say pardon me and please a lot. And pardon me for the way our planet isn't working. And please let us help do something about it. But then the other thing that brings me hope is that I do a lot of work at global levels in science and science education space. And there is a lot of momentum about doing science education differently so that we think about systems, we get away from isolated facts, we think about sustainability. And so we can find ways to do science, to do education as if people matter and as if our planet matters. And that gives me a lot of hope.
Yeah, but Peter, I think that's a great perspective and thought and sentiment. But what's at the center of what you're saying is that it's not just the knowledge that something is happening. There's the understanding of why it's happening. And that requires a level of science literacy that you are championing here. Do you have hope for the world? If the world does not achieve the science literacy you think they might need to really embrace the problem?
Science
and not have it just be a superficial thing that they heard about at the coffee lounge?
You know, if chemistry keeps being taught the way it's been taught for the last 100 years, where it's a whole bunch of isolated facts that you memorize, and then it's hopeless. But that's not happening. There's fundamental change happening in science education, and it is focused on systems thinking. It's focused on sustainability, and it's a train that's moving. There's no way that train's stopping now. You see it in the next generation science standards in the U.S. You see it in science and sustainability initiatives. You see chemists and scientists working with people in the humanities and social sciences and the fine arts. We're on the train, and it's moving.
That's a very 19th century reference there, on a train. See, in astrophysics, hey, we're on a rocket and we're going fast. Okay. Just consider using a more updated vessel for this.
But you're an astrophysicist, so you think about rockets, right? And we're writing a children's story about getting a train over a mountain from Venice, which is flooding, to Paris. And we're asking kids to think about what locomotive is going to take them there as a way of talking about
okay.
So trains are in my mind. Yeah, it's Thomas the Tank Engine, told by a chemist.
Yeah, we got that. Well, Peter, thank you for this sharing this expertise. Can you hang on for Q&A?
Sure.
Yeah, excellent. So let's go to the final part of this live, this StarTalk Live on climate change, the science, the sociology, the citizen science part of this. It's all one thing. And to now turn it to the Q&A, we'll get to know what all of you are thinking. Many of you are science teachers because you're in the pool of people who know about and support Pocket Lab's mission, as do we. So that's great. So Peter, thanks for staying on. And I want to introduce someone who's actually collating the questions for this segment, and that's Dave Baker. Dave, are you there?
I am here. Can you hear me?
Excellent. It's great to be doing this again with you.
Yes, great to see you guys.
Yeah, you're co-founder of PocketLab. We'll brag on you a bit here. Co-founder of PocketLab and a teacher and a mentor at Stanford University in the Graduate School of Engineering. So you got some good engineering chops behind that. And you've been collecting questions this whole time.
I have. We've gotten thousands of questions. So
thousands, yeah. So let's start now, and we'll see how.
So hopefully you're not tired. Get some coffee.
We'll be out here by Tuesday, right?
I think so.
Okay,
and I'm
let's do it.
That too. If a good one comes up, we'll try to grab it out of the chat. But
okay,
yeah. So
and you're delivering all the questions. Is that correct? Just for efficiency. Okay, good.
I got them all.
And if you can identify who said the question, that'd be great.
I will.
To give them a shout out. Mm-hmm.
I will. So, I have the first question just dives right into some of the stuff you've been talking. I think this would be a good summary. And this is a question is from India, and it's from Shiva Mishra. And the question is global warming really caused by humans? Earth is warmed and cold before when there were no humans, and the amount of CO2 released by humans is less compared to other sources. So it's really interesting to hear, a skeptical question from India, right?
Yeah,
Peter, what evidence you have that it's us, Peter?
Yeah. Well, it's more than the chemists, But that's a great question, Dave, and thank you for that question from India. It's a question a lot of people wrestle with, because if you look at data that goes back, and we've got really good temperature data going back millions of years, but if you look at the record that comes from ice cores going back 800,000 years, what you see on those graphs of temperature is that the temperature goes up and down over that 800,000 years. And sometimes we're in ice ages, and sometimes we come out of ice ages. The temperature may changes 10 degrees or something like that in between those periods. And parallel with that, correlated with that, are the concentrations of these greenhouse gases. So what are we so worried about with 1.5 degrees of warming over a period of time? And so in order to address that, we created an interactive resource at kcvs.ca, the Visualization Center, and it invites you to take all of that data and graph it, and now go in and examine the data, interrogate it, and ask some questions about it. Don't tell people what to think, but look at the data. Can you ask some good questions? And what you find is, if you go to one of the periods in the last 800,000 years where the temperature is going up the most steeply, and you measure the slope of that line of temperature versus time, and then you compare it to the slope of that line over the last 200 years, you find that one thing is different, and it's rate of change. Humans are causing the temperature to change since the Industrial Revolution at a rate we haven't seen before. And so, yes, that's what the big difference maker is, and that's what the great acceleration is. That's why we talk about leaving the Holocene epoch and entering the Anthropocene epoch, where our human imprint is fundamentally changing the life support systems of our Earth.
Right. So what you're saying is, yeah. So if Earth has been through this before, but just got into it a little more slowly.
Right.
So what's really going on is we spent thousands of years building what we're calling civilization on this sort of plateau of climate stability.
Yeah.
And so the simple fact of climate change is not itself a problem. It's that it's a climate change in the face of a civilization that's not built to anticipate climate change. Is that a fair characterization of this?
Yeah, that's a great characterization. And then if you think about when, Catherine Hayhoe was talking about when human civilizations really began to emerge, and they're in the Holocene, and when agriculture happened. And for most of the last 12,000 years, we haven't seen a change of more than about 1 degree Celsius in the average surface temperature of our planet. And so, sometimes people call that sometimes the Garden of Eden. It's a place where humans can thrive and our planet can thrive. And now what are we doing? Since the Industrial Revolution, we've gone up almost 1 more degree since 1750, and we're on a trajectory by the end of the century to go up 4 or 5 or 6 if we don't do anything about it. And if we do a whole bunch about it, maybe we can keep it below 1.5 or 2 degrees.
So the deal is, this is all measurable, number one, quantifiable, and identifiable. It's us. We are the ones that are doing it.
That's right.
We are the ones.
We are the ones. We are the culprits.
All right, Dave, bring on another.
Well, that's good. So the data is this proverbial hockey stick, right?
Yeah.
Mm-hmm.
Yeah. Well, and it's funny that
And he's Canadian, so he really appreciates it.
I know about hockey sticks.
By the way,
Right.
this is you have to call us the Great White North edition of StarTalk. We had 2
No, Dave. No.
Hey,
Chuck, don't play that. Chuck, don't play that. All right, Dave, give me another one. What do you have?
Yeah. So here's a question. This is from Vanessa Turner of Canada, another Canadian. How can we make climate change education less preachy and more about the data? Are there places where teachers can access climate data in easy to process, understand ways to use in the classroom and allow them to manipulate it? It's basically what you just showed. But what are the resources that can make this more about the data, less about the, you better be good.
Less about choosing sides.
Yeah, right.
Well, it's, I was talking about trying to depoliticize the conversations, and that is so hard for teachers to do. And all of us know that all you have to do in education is tell people what to think, and it works, right? Lots of good examples of that in history. That doesn't work. And when it comes to something really controversial like climate change, what we've got to do is find ways to give students tools to examine the data and ask really good questions. And, so that tool that I was just telling you about to actually measure the slope of temperature over 800,000 years, that's exactly the kind of thing that's needed. And there's super good sources out there. You'll find references to a lot of these at kcvs.ca. There's other really reliable sources for teachers. The National Oceanic and Atmospheric Administration in the States and NASA have incredible resources where you can provide data to students and you can help them ask really good questions about it.
But of course, people have to know, they have to want to do that. And so often people just refuse up front, and then they just carry this misinformation with them and then further spread. then it shows up on political tracks. Right. I mean, the challenge, I think we're all going to die.
I plan on it, Neil.
Oh, you want to plan on it.
By the way, for those teachers out there, that's a great lesson. There you have it. Like let that be lesson one.
No, it's important to know that these tools are out there, whether or not you knew it. And I know about the NASA tools because I'm closer to them, but all the rest of these tools, Peter, that you're listing there, and we'll make sure we have accurate, good links in the when this finally posts.
Yeah,
Dave, we got about 10 minutes left. Yeah. Let's see if we can get like a lightning round maybe, so we can get through some of the 1,000.
Sure. Well, I have just a quick one for Peter too, and then let's go into. I got a great lightning round questions for you. Is there an experiment, Peter? What's an experiment like elementary or middle school kids could do that illustrates what's going on?
Well, there's a lot of really basic ideas about climate that you can introduce at that level. And those ideas have to do with the difference between climate and weather, which a whole bunch of adults don't seem to know about. But kids can get that when they think about, the weather that they experience over a long period of time. That's climate, and the weather they experience day to day or hour to hour. There's other things that young students can do to begin to understand heat flow in our atmosphere. Give them a little infrared camera and have them start looking at that infrared radiation that they can't actually see. And boy, they're puzzled by that. And then give them an idea that just like light, visible light can be absorbed by things like a colored solution, that infrared light from an infrared, a little laser that you can use to detect temperature. It's that interacting with these invisible colorless gases in the sky that's actually causing our planet to get warmer. And there's a model that can be used when you get just a little further in with kids, maybe into middle school, that breaks down the problem of our changing the radiation balance of our planet into a couple of really simple parameters that you can actually change and play with. And you can change the temperature of our planet by moving it closer or further from the sun, by changing the amount of light that reflects off of white and bright surfaces on our planet, the albedo, and by changing the amount of greenhouse gases. And so again, at kcvs.ca, we've built a little interactive simulation to help young kids play with that. And it really helps with understanding that.
Wait. It's to help adults too, grown-ups.
Yeah.
Absolutely.
Here's what I learned from that last answer. It is better to go to public school in Canada where you can get an infrared camera. He said infrared camera. I'm like,
give that to the 8-year-old kid, right?
Not in America. Not in America.
No, America.
Sorry.
America. You know how we do that in America.
There's a lot of heat flowing, but it's mostly political, right? And it's
political heat, a lot of hot air.
Right. There you go.
Hot air. Right. Dave, keep them coming. We got a few more minutes.
Well, these are some. I got some rapid fire questions for you, Neil. I think most of these were directed at you, but you guys might have some fun with these. There's some interesting ones here. So, from Irina Raman, would you rather be an expert in one thing or a novice at everything?
That's for you, Neil.
Definitely an expert in one thing. Oh, because then you...
Spoken by the man who is an expert in many things. Shut up. Next question. Jesus Christ, stop wasting my time. This guy's an expert in so many things. He's like, I'd much rather be an expert in one thing.
No, here's the thing. No, I'll repeat something I've said before.
Go ahead.
One of the big challenges in life is knowing enough about something to think you're right, but not enough about that same thing to know that you're wrong.
Ooh.
Yeah.
And we have too much of that second case influencing policy in this world. So I'd rather be in a sea of experts. And if I need an expert on something, I'll go to somebody else. I don't need you to know everything. I'll get somebody else who's an expert in that. That's how I'd like to think about this problem.
See, and I've been married for 24 years, and so I know that I am not right about anything. So.
Okay. I want to come back to you, Neil, about that in one specific way. I agree with you completely. And when it comes to teachers and climate change, one of the biggest problems we have, it's a problem I faced early in my career as a chemist moving into climate change education, and that's I'm not an expert climate scientist. I'm not Catherine Hayhoe. And so we have teachers all around the world saying, I'm not an expert, so I can't teach climate change science. And so what we need to do is find ways to get them resources, to get them working together, to to tell people when they don't know something, but still to dig in there and make connections to the things they teach, because otherwise the game's lost.
And let me just say this
something.
very quickly on top of that, Peter. Climate change is such a large problem that no matter what you're an expert in, climate change touches it. So all you have to do is make the connection to climate change where you're an expert.
That's right.
As I've done, I just talk about the runaway greenhouse effect on Venus. But I live in New York City, which is a media capital, news media, and I get called all the time. Could you comment on the wildfires and the climate change and this? I said, no, get a climate change expert. They call me because I think they're lazy a little bit, because they know how to reach me, and I'll give them a good soundbite when it's relevant. I'd rather they go back to the Rolodex. So what we need is more climate change professionals out there reaching to the public. And
here's what I love.
I don't see more. I'm tired of seeing my own damn face up there talking about this.
Here's what I love. I love the fact that Neil has this like humility where he doesn't understand they're calling you because you're freaking Neil deGrasse Tyson. Okay. And he does this. Let me tell you something. I've been working with Neil for
their climate expert. Get him a climate expert. Okay.
But the deal is this, man. It's like, who do we know? Oh, who's the number one science communicator in the country? Oh, let's call that guy, right? But he's like, don't call me. Call an expert.
And here's another problem, Neil. Most scientists, including climate scientists, aren't very good about communicating to the public the stuff that the public needs to know. So that falls on us as scientific community. We got to do a much better job of that.
Plus, good scientists have to couch their statements in probabilistic terms. They say, are these definitely related to climate?
Neil,
we're having trouble with the audio. He's speaking with his hands, though. We can understand.
Your microphone connection, I think, is loose because we're picking up a great deal of static.
How's it now?
No, it's the same.
Oh. Hang on. My bad. Now? Nothing.
No.
They're better. Try again.
I don't think tapping on the mic is going to make it better.
Hello? Nothing.
Does this mean, Chuck, you're giving Neil static?
Okay, so nobody can hear me.
No, we can hear you. You're just very staticky. You're breaking up. So
really?
And it's not a connection because your visual is perfect.
Oh, okay. So let me just check on this here. Hold on. Yeah, my connection seems legit. And now, am I okay?
No.
Oh man.
That's still breaking up. Yeah.
We can make it out.
Okay, Chuck, you're gonna have to finish this out.
Okay. So here's the thing, guys. Just ask me anything as long as it has nothing to do with science. And now we will take any questions on jokes about your anatomy.
Neil, I think you're back on. I think we're hearing you now.
Oh, yeah, you're back.
There we are.
Okay. Very nice. Very good to know that.
Next,
give me a few more questions before we got to call it quits
couple
here.
Good ones. There's a lot of viruses on people's minds. So here's a question from Rhonda Hakimovich. Are there viruses in space?
Well, we know there are amino acids in space, which are the building blocks of proteins, and proteins are fundamental to all life. So we don't know whether or not there's viruses in space. But to make a virus, space is really empty. It's really empty, and to make interesting molecules, Peter will attest to this. To make interesting molecules, you need a medium where the atoms can get together and make an interesting molecule. And if you're in a gas cloud that's rarefied and space is empty, and I've said this to Chuck, he freaked out. If the period at the end of a sentence, if you shrunk the sun down to the size of the period at the end of a sentence, the next nearest star is 4 miles away.
That's amazing.
Space is empty. So space is not just the ripe place to go look for complex molecules. That's all I'm saying.
Okay. Well, hey, here's a good follow-up on that.
Okay. The
viruses on people's mind. So which is worse, COVID-19 or Pluto being demoted?
Worse for whom?
Yeah, I was about to say.
But I think Pluto's happy now. Pluto is like the biggest object in the Kuiper belt of icy bodies in the outer solar system, whereas before it was the puniest planet. So I think Pluto is happy.
Yeah.
Okay.
It's no longer masquerading as a planet. It can
Exactly.
be itself now.
It's completely legitimate in its
Right.
own skin right
Exactly.
now.
And Pluto didn't harm anyone, so.
Right. No one died talking about Pluto. Right. Give me one more.
Okay, I'll give you my favorite one. And this is from Bangladesh. It's from Nasrullah I hope I'm saying that right, in Bangladesh. Okay, this is a good one. If a human colony is established in Mars and a child is born there and raised there, if the child visits Earth, would he be considered a human or an alien?
It would be an undocumented immigrant.
And I'm sorry, we got to make planet Earth great again, guys. So
Build that wall.
Yeah.
The question is not whether you'd be. The question is not whether you'd be human. The question is you'd be a citizen of what country. That's the question.
Yeah.
Right, and Peter, you can test chemically whether they're actually human and they're not some Martian in a human costume.
Well, I was just going to say we'd probably take her in as a refugee.
Yeah. Oh, Canada!
Wow, that's so Canadian.
That's a Canadian thing. That's so Canadian. Okay. Well, we got to close out this show. This is the first ever virtual StarTalk Live. It's been fun to put together, and of course, we had a little bit of technical glitches, but I think the content all came through. I want to thank Chuck. Nice, Chuck.
Such a pleasure, always.
All good. Catherine Hayhoe, who did our first two segments. Peter Maffey, if I say that right, and of course, Dave Baker. And I want to publicly thank PocketLab for co-sponsoring this event. So this has been a production of StarTalk. And I've been your host, Neil deGrasse Tyson, as always, bidding you to keep looking up.
Good night.
Good night. Thanks.
Right.